Well, I am assembling the K3 now, Krasnogorsk camera, and finishing the motor modification. You can see this black stuff here. There was the original speed selector, and I had to take it off because on Krasnogorsk 2 it's not too high for the motors, but on K3 it might be. So it's kind of case by case basis, but I of course need to cap the hole with something if taking the knob off. So I took it off and then used black epoxy glue. That's hard epoxy glue on the hole, and before applying that I used aluminum tape. On the other side it's just aluminum foil with glue. The stuff used in construction, but that stuff will last for years, so you can leave the tape there. No need to take it off. It's reliable, and this epoxy glue also is reliable. So I removed the motor just to apply this, because I didn't do that before. Then you can see that brown colored spacer there. So I 3D printed a temporary spacer. And this particular camera, because where is the front? It is EF modified camera, and the flange focal distance is different than on the original one, so I couldn't use the original spacer, and actually this one didn't have spacer at all. I think the previous owner had lost the spacer, or it was taken off and thrown away when installing the EF mount. So this is temporary spacer, and I'm making some tests with this. This one focuses infinity, but more testing is needed than I can do here. So, and this is PLA, just regular PLA 3D printed. And 3D printer has tendency of, because you have the, what is called, the printing surface, the plate where the printer prints the object, so it's almost impossible to get that so perfectly in level that the spacer would be exactly same thickness from both ends. So it varies just a tiny bit. It's like 1/50th of a millimeter or so. I'm using micrometer screw to test this. So you will need something like this if making spacers. It's pretty much impossible to know if the thickness is right unless you have good enough tools. So this measures in 100 millimeter accuracy. It's an old Soviet one, but it's accurate, so I'm using it. So 3D printed spacer is never good enough. Maybe if you grind it perfectly level, but this works as temporary spacer, so one can shoot with this maybe 2 months, 3 months. Then when figuring out the exact correct techniques, I don't have all the tools to test it here, but when figuring out the exactly correct thickness, then one can use the cut models I included to the folder to get final one made from aluminum or stainless steel. So you will send the file to some machining company, and they will either print it or CNC machine it. So new spacers can be made, and I included pre-cut thicknesses in 1/20mm increments, and then there's the 5mm thick version which you can cut in cut software by yourself. So spacers available, they are included with all the 10-speed and 4-speed motors, and if I will release some other versions, so just this one I printed today. So the idea is that if you buy the where I do have it there. So let's see. One can order the 4-speed motor as a kit without any casing and over long wires, and the idea is that if you are designing your own motor casing, then you can use this kit, because just connect the power source and this will work in crystal sync. But I was wondering how easy it would be to design a 3D printable motor casing which you can just purchase the electronics kit without any casing of the 4-speed motor, and then in the same folder than where I put all this stuff and axle adapters and cut files of these plates and so on, I can just put some models of 3D printable motor casings, and you will just take the electronics kit, then maybe shorten some wires and then put it here, and you will need to arrange the connector. But I can even make front panels for this, because the panels, I have some panels, it's not any motor panel, but panels like this are very easy to get made in China. So I can include the CAD file of the 3D printable casing. You can design your own casing, of course, but I can make front panels for the casing I am designing, and if you are using the same spacing on the screw holes, you can use the readily available panel for the motor casing, even if you design this stuff by yourself. With this took a couple of hours to design. It's not perfect, but it does work. So, and it's designed so that you don't need to cut the wires when threading them. So instead of making a hole for the wires, I made a groove for the wires, and then when installing the front panel, the wires are secured there. So, and if using the temporary switches which I include to the electronics kit, then you can just mount the switches here without cutting the wires again. So if there's lots of extra wire, you may need to shorten that, but otherwise you can just put the electronic kits here without cutting any wires. So it's looks a bit funny compared to the aluminum stuff I make, but this does work. And even if you 3D print it out of PLA, you can use it for a couple of months, maybe a year before it breaks. I'm assuming about half a year. So you can just buy the electronics kit from me and then 3D print motor at home and use it right away. It's not as good as the aluminum ones, but it does work. And you can see this is the first version, of course. I can include the CAD model of this if you want. Because, like I said, it took a couple of hours to design this. I can just make new ones. I like making this. So, and you can make your own, and if you make your own and it's good, I recommend to share it with other people. And I just like to make the electronics kits, and then it would be fun to see what kind of stuff people invent. The electronics can be used, but so power connector, I can include the connector. They are cheap, so I can include that, and then with the electronics kit, and then some kind of control panel if you want it. I can include it anyway. If you're making the whole casing by yourself, then I want some mention somewhere that the electronics are made by me, so that you didn't design the electronics, you designed the casing. Of course, it's your casing design, but I wanted it shows somewhere that I designed the electronics, because those are most work. So designing the electronics may take a year, and designing the casing takes a couple of days, so that's the difference. But I can include CAD models like this, even this first one if you want. It's no problem. I think this one I used to find out how much room I need for the boards, and especially for the wires, if not wanting to shorten them too much. So, and you can see these are ventilation holes, but I made them so that the switches fit here. And if using with ACL, you can just invert the switches here. So. It costs like $2 to make this kind of control panel in aluminum if no finishing, manual finishing needed. So I can include the panel like this, and you can use it. It's cheaper actually than if I include the file for the panel and you get it made by yourself. It's much cheaper if I get it made, because you need to order like 20 to get them at reasonable price and shipping costs and so. And if you're ordering the electronics kit, then why not take the panel? You don't need to use it if you don't want. Just add to mention that Krasnogorsk electronics designed by APA. That's enough. You can design your own panel. But this is cheaper if I just make the panel for you and include it. And I'm collecting orders for the electronics kits for 4-speed. And like I said, I don't include motor casing. You can get, if I design this 3D printable casings, then you will get all those files for free. And you can design your own if you want, or use the file, or first 3D print one of the files and then later on design your own casing. So this is pretty easy, and it's comparing to the, this is the aluminum version. Aluminum version is smaller because it's not made to be easily assembled. So I need to cut the wires and everything to fit stuff in this tiny aluminum casing. It's more durable than the 3D printed one, but this is more expensive. So this is $650 with shipping, and the electronics for this cost about $400. And the casing maybe costs like $5, from $3 to $5 if you print it by yourself, or maybe 10, 15, I don't know, maybe $10 if you get it professionally printed from better plastic. So that's the cheapest motor I have for now. You need to 3D print the casing by yourself, because I don't usually have time to set up the printer in my bathroom and wait for like 8 hours for it to print this, and not being able to do anything else like soldering in the meantime. So I don't want to print these casings for you, but if you have a printer, you can print it by yourself. And trying to not break something. So you can see this is the first design, but you can see what I did to make it last better if it's PLA or another fragile plastic. So this area where the switches are cannot be really thick, so that it's possible to fit the switches, but I left material here so that this strengthens the body so that it doesn't break. It's pretty sturdy. This is really cheap PLA. Not very good printing quality, but this does work. You can use this with camera. And most importantly, these 4 screw holes, the mounting is exactly the same than on this motor. It's exactly the same. I just left the holes a little bit larger. Let's see, 4mm screw. So when printing it with these cheap plastics and cheap everything, then it's common that the screw holes swell a little bit. Or there's imperfections, and then you need to manually finish it. And if using cheap plastic and cheap printing and everything, then drilling this is not always the best idea, because this is the filament printing. So this is basically a thin plastic wire, all stuff. So you can break the inside of the hole if trying to drill this too aggressively. So I intentionally left the holes larger. This also means that this cannot be CNC machined, and details like this cannot be CNC machined. So if trying to make this out of metal, you would need to 3D print it anyway. So I can design you a metal case, but don't use this one. The CNC place will say no, because this is not meant to be machined. This is meant to be 3D printed, and it would be horribly heavy if made out of metal. If designing stuff for metal, I don't need this much thickness to this weak point, for example. This is much thinner. This is way thicker than it needs to be, but that is because one can mount battery plates here. You can mount battery plates reasonably for this type of system. Maybe if it's ABS plastic or something, but you will need to design the battery plate by yourself, because this plate does not fit, because the spacing is different for the screws. But yeah, if you really need the battery mounts and everything, then I still recommend ordering the metal version. Readily assembled metal version of the motor if you want to save money and don't need any extra stuff, just something which works in crystals and can use the same mounting parts, then this is a good option. It's the pretty normal 42 BLS 01 motor, but with custom max. So you can ask the factory to make you this, but they want to make at least 50 at the time. So just if you want this motor, just order this. Then for me, I can sell this separately if you want. Anyway, so I will test this next month, but I don't have time right now. But this design seems to work fine. So back to the Krasnogorsk. So I was going to make Krasnogorsk video, but I was so interested in 3D printed motor that I forgot what I was going to do. So yeah, I blocked this and then the front panel, the mirror cutout blocked. I just super glued this stainless steel plate. I have this nice, very thin stainless steel stuff, which this is used for solder paste mask of the circuit board. So I get from the circuit board factory, and I'm taking the solder mask area out and then using this leftover stuff or something else, because the mask plates are much larger than the actual circuit board, because I'm manually making them, not the panels. So use this funny little stuff here. So I always, when installing the electric motor, you need to take the original start button off. But I didn't glue the button back. I just filled this again with black epoxy glue and use this connector. Leftover, where is CX foil connector. So I use the leftover connector here to keep the glue plug in place, so that it cannot. It should not, but I don't want any possibility that this glue drops into the movement, other mechanics, so it cannot drop. So here's the mirror cutout, and I added just a tiny piece of neoprene foam there, and it's blocked with the stainless steel plate from the other side. And a nice trick, if you need to light proof small holes like this, then cut a tiny piece of foam material like this and just use some screwdriver or something to fill the hole with it. So cut a tiny piece of this and put it to the hole. And I will do that trick with this cable release plug here. So I need to fill that too, so that it doesn't leak light. Otherwise, this is pretty good. I need to clean the mirror a little and then put this together. It's perfectly fine. And then testing with film and tiny bit of cleaning from there. Then testing with film and then putting the motor back on. So on. And this seam between, when putting the front back on. One may leave just tiny 1 millimeter or half a millimeter or quarter millimeter seam between this and the plate, and it's possible to get tiny bit of light from there to here, which can after that leak just a tiny bit from this opening. So I need to block this again with foam. That's the easiest way to do it, because it must be removable when opening the camera for servicing. So I will put a tiny piece of foam material there to block the light leak, and then when the camera is opened for servicing, then I can just take the foam off. I'm not servicing this, but the one who is servicing this will take the foam off and then put it back. Camera back together. So I have this temporary spacer here, and light leaks pretty much, except that one. So one always needs to check. So there's some space between the lens mount and this hole. So I will need to block that with tape or this piece of foam after putting the camera together. Otherwise it's good. So I'm assembling this and then testing. And this will going to use the 10-speed. I'm not mounting the 4-speed for testing, because I'm sending this to the customer with 10-speed, so I'm using 10-speed right away. But I'm assembling this side and then the motor back together.